So, who really gets to shape our understanding of the universe? You'd probably think it's just the experts, the ones with fancy degrees from elite universities. But the history of science, it tells a totally different story. Today, we're going to dig into the wild origins of some of the biggest ideas in physics, ideas that came from the minds of complete outsiders. Let's get into it.
When you think about modern physics, a lot of it just sounds, well, weird. I mean, even Albert Einstein himself called quantum entanglement spooky action at a distance. The idea that two particles could be on opposite sides of the universe and still be instantly connected, it honestly sounds more like magic than science.
And yeah, that reputation has totally stuck. Quantum mechanics often gets this rap as being some kind of unsolvable mystery, just packed with paradoxes that make no sense to us. But is that really what's going on?
And this right here, this is the myth we all hear about. We get told about Schrödinger's cat being both dead and alive, or particles that are in a bunch of places at once, and it feels like it just shatters the basic rules of reality. It's a really common idea, and the way it's shown in movies and TV definitely doesn't help.
Okay, but here's the thing. Our source material makes it really clear that quantum mechanics isn't some mystical belief. It's a mathematical framework. And it's an incredibly successful one at that. It makes these super precise, testable predictions that have been proven right over and over and over again in experiments. So, while the results might feel totally foreign to our day-to-day lives, it's not weird for the sake of being weird, it's just how reality works on the tiniest scales.
So that gets you thinking, right? If physics is this very structured mathematical thing, then who gets to add to it? Do you really need that PhD from a top university? Do you have to be part of the in crowd to come up with a truly revolutionary idea? Well, you might be surprised. History tells a very different story. Some of the most foundational ideas we have came from people on the outside, these unlikely geniuses who sparked a revolution from the fringes.
I mean, just look at this contrast. On the left, you've got the stereotype of a scientist we all have in our heads, the degrees, the professorship, the whole academic 9 yards. But on the right, that was the reality for some of the most important people in physics. A brewer, a bookbinder's apprentice, a telegraph operator. Seriously, these were not the people you'd expect to be rewriting the laws of the universe.
And this slide just lays it all out, and it's incredible. You've got Michael Faraday, who basically taught himself science by reading the books he was supposed to be binding, and he gave us the entire concept of electromagnetic fields. James P. Joule, a brewer, gave us the first law of thermodynamics. And then there's Oliver Heaviside, a self-taught telegraph operator. He took Maxwell's original super complicated equations for electromagnetism, there were 20 of them, a total mess, and he turned them into the 4 elegant equations we use today. He didn't just make them simpler, he unlocked their true power.
And you know what? This reaction from a Reddit user who just learned about Oliver Heaviside's story just nails it. It's that feeling of complete shock. You just assume these giants of science have these perfect academic resumes. The truth is just wow.
So, this is the big question, isn't it? How did they pull this off? How did these people, who were often looked down on by the academic world, see things that the trained experts completely missed? Well, the answer is actually in the way our brains solve problems.
To really get how they pulled this off, we have to look at both the power and the danger of being an expert. And that brings us to something we all know: thinking inside the box.
Okay, so thinking inside the box. It sounds bad, right? But here's the twist. According to cognitive science, it's absolutely vital for making any progress. It just means using the facts and methods that are already established in a field. I mean, you have to know the rules before you can play the game. It's the bedrock of expertise.
But, and this is a big but, that same expertise can be a trap. When you're an expert, you get really good at solving problems using the existing rules. And the whole system of science, like peer review and getting funding, is set up to reward that. But that can create these massive blind spots, making it almost impossible to see when the rules themselves are the problem.
So what do you do when the box just isn't working anymore? Well, you need that aha moment. You need a leap outside the box. Take a look at this. It's the famous Knizia triangle. And it is the perfect way to think about this. What do you see? You see a white triangle, right? Pointing up. But look really close. There's no triangle actually drawn there. Your brain is creating it out of the empty spaces. That is what insight feels like. It's not about just analyzing the pieces you have. It's about totally reframing the problem so you see a new pattern that wasn't there before.
So the key here
And this is really important, is that insight isn't just some lucky guess. It's a real cognitive thing that happens. It's that moment your brain finally breaks away from a bad mental model and just rearranges the whole problem. And all of a sudden, the solution seems simple, even obvious. It's that eureka moment that changes absolutely everything. Okay, so when you put it all together, the real process of discovery kind of looks like this. You start with what you know. You work hard inside that box. But for a really tough problem, you're going to hit a brick wall. And that frustration is what pushes you to let go, to look for an insight, to reframe the entire problem. And once you have that aha moment, bam, the solution is right there. It's this beautiful dance between deep knowledge and a wild leap of imagination.
So what all of this really shows us is that science isn't this cold, clean process of just plugging in formulas. No, it's deeply human. It's full of intuition and frustration and these sudden brilliant flashes of creativity.
And this visual from a game called Mindle, it shows this perfectly. Those small, choppy little peaks, that's thinking inside the box. It's making tiny, step-by-step guesses, trying to get a little bit closer. But then, look at those huge jumps. Those are the aha moments. That's where the player just ditches the old way of thinking and takes a massive leap to a totally new idea, getting way closer to the answer.
And really, that's the big takeaway from all this. Real progress, real game-changing innovation, it needs both. You absolutely have to know the rules, but you also need that insight, that creativity, and frankly, the guts to know when it's time to just throw the rule book away.
So let's bring it all back to our guys, right? Faraday the bookbinder, Heaviside the telegraph operator, Joule the brewer. These guys weren't just lucky amateurs. They were masters of the aha moment. Because they weren't so deeply stuck in years of formal academic training, their minds were free. They didn't have the institutional blinders that can hold even the smartest experts back. They could see the patterns that everyone else was missing.
And that leaves us with one last kind of mind-bending thought. If the biggest breakthroughs happen when someone challenges the rules, it really makes you wonder, doesn't it? What fundamental rules are we holding on to in science today that are actually holding us back? And who's going to be the next outsider to see the thing that the rest of us just can't?